Elizabeth, and thank you for the organizing committee to give me the possibility to present my work. So of course I have no disclosures. So my topic is burning out the T-LLA engine. And NADK is a new therapeutic target in T-cell acute lymphoblastic leukemia. So T-cell acute lymphoblastic leukemia, or T-LLA, is an aggressive cancer that is most common in children, but also affects adults. T-LLA remains fatal in 50% of children and 50% of adult cases. And there is a real unmet need for new treatment in T-LLA. So most cases of T-LLA are driven by mutations in the Notch1 related gene, and we were set out to identify therapeutic vulnerabilities of Notch1 driven T-LLAs. To find these new therapeutic targets, we performed CRISPR-Cas9 genome. So the CRISPR-Cas9 genome wide screens the genes for genes that T-LLA relies on to survive. So we use this specific pipeline to determine which genes are essential for the T-LLA to survive. We then isolated the genes that are specific to the Notch1 mutation and driven the Notch1 driven T-LLAs, and then understand the mechanism and test therapeutic potential. So we identified the metabolic gene NADK as a new therapeutic target, and the mechanism is the following. So once you have an activated notch, this one will push the T-LLAs to proliferate by activating different programs in the genome. And this proliferation of the T-LLA creates a lot of byproducts. These byproducts, in this case, a reactive oxygen species, or ROS, are toxic for the cells. So in that case, Notch is also going to activate NADK that will then produce different substrates that will neutralize the byproducts in the leukemia cells. So in that case, the T-LLAs will be able to proliferate. And if you target specifically NADK, you are choking the T-LLA cells, and they will stop proliferating. So preclinical studies show that genetic and chemical inhibition of NADK stops the T-LLA cells from growing in vitro and in vivo, and this without any significant toxicity. So in conclusion, NADK is a promising therapeutic target in T-LLA. There is an available inhibitor, thionicotinamide, but unfortunately, it's not powerful enough for clinical use. So we are looking and starting the development of new inhibitors to test alone and in combination with standard chemotherapy. So I would like to thank the different collaborators that have participated in this project, and also the different funding bodies, and your attention, of course. Thank you.